Okay, so in this section, we're going to look at our last two truth tables. The first one will be for our if-then, our conditional statement, which is our arrow, and then we'll go on to the biconditional. So remember, the conditional statement is the only statement that has to be in a specific order. And that means you have to be careful when you're evaluating true and false in your truth table. You always have to go from the antecedent to the consequent. You have to go in the direction of the arrow of the conditional statement. Let's look at an example where P is you get an A in the class, Q is you pass the course. And I want to evaluate the truth value for the conditional statement. If you get an A in the class, then you pass the course. So again, we have our if, our then. You get an A in the class is P. You pass the course is Q. So this is our conditional statement. Now it might be easier for you to understand why if P then Q is true and false. If you look at this as being a promise, pretend like I am promising you that if you get an A in the class, then you'll pass the course. Let's create our truth table. P is going to be true, true, false, false. Q is true, false, true, false. So let's say we have true, true. P is true, Q is true. Let's say that you do get an A in a class and you pass the course. Is my statement true? Did I tell the truth? So my statement is if you get an A in a class, then you pass the course. So it's pretty clear that it's true. I told the truth. What if it's a true false? What if you do get an A in the class, but you do not pass the course? Is my statement, if you get an A in the class, then you pass the course, true or false? And it's probably clear that I lied, and the statement is false. Now here's the fun one. What if we have a false true? Let's say you did not get an A in the class, but you still passed the course. Is my statement true? If you get an A in the class, then you pass the course. And the answer is, it is true. It's true because my statement says nothing about whether you will pass or not pass if you do not get an A in the class. This statement only says what will happen if you get an A. If you do not get an A, who knows? I could do whatever I want. Think about it this way. What if you get a B? If you get a B in a class and you pass the course, seems reasonable, doesn't it? But you didn't get an A. So you see, it is reasonable to go from false to true in a conditional. What if you have false, false? What if you did not get an A in the class and you did not pass the course? Is the statement, if you get an A in the class, then you pass the course, is that true or false? The answer is, it is true. False to false is true in a conditional statement. Again, I did not make any claim about what would happen if you did not get an A in the class. So you could pass, you could not pass. My statement is still true. Look at it this way. What if you got an F in the class and you did not pass the course? Reasonable? Yes, sure. And that would be a false, false case. So if you don't really understand why the truth table is the way it is for a conditional statement, that's fine. Just make sure you know how to use the truth table. Notice that the only time a conditional statement is false is when we go true to false. All other cases, the conditional statement is true. And the reason why true false is false is because think about this. You're starting with something that's true, then you get to false. That cannot happen. Why this is so important, this conditional, is that, again, going back to our goal for this chapter, our goal is to decide whether an argument is valid or invalid. All arguments are conditional statements. The if, those are the reasons why. The then, that's our conclusion. So there's no way you can have true reasons and end up with a false conclusion. So when we decide whether arguments are going to be valid or invalid, if we get a false for the conditional statement, so that would be going from true to false, then our argument is invalid. So let's move on. We'll just kind of let that simmer. And we'll do some examples where we're just constructing truth tables. We have an example 1, if P then not Q. So again, we should be on autopilot by now. P is going to be true, true, false, false, Q, true, false, true, false. So there's no not Q in my table. So I first have to figure out what not Q is before I can figure out if P then not Q. So if Q is true, false, true, false, not Q is false, true, false, true. Remember, our conditional statement is an arrow. We are starting at P and then we are going to not Q. So in this first row, we're going true to false, which cannot happen. So our conditional statement is false. The next row, we're going true to true, which can happen, that's true. And then false to false is going to be true. False to true is going to be true. So for these last two rows, it's going to be true and true. Let's do another one. Okay, so we're going to construct a truth table for this hot mess. We have PQ, true, true, false, false, true, false, true, false. So some people get overwhelmed when they see our statements getting really large, but remember, just follow the steps. I see grouping symbols, which tells me I have to work with the innermost grouping symbols. In this case, it is the parentheses, if not P, then Q. I have to work within those parentheses first. I have Q listed, but I don't have not P, so I need to do not P before I can do if not P, then Q. So P is true, true, false, false, not P is false, false, true, true. So now I'm going from not P to Q. So again, remember the order matters here. We are going from not P to Q. So this is actually false to true. So sometimes it's helpful if you write it down off to the side. Not P is false, false, true, true, and Q is true, false, true, false, just to make sure the order is going in the correct direction. So if we're going false to true, that's true. If we're going false to false, that's true. True to true is true. True to false is false. That is the only case where the conditional statement is false. I'm still working within my bracket. I now have to do an and, not Q. But I don't have not Q listed, so I'm going to first, and I always do that. I'm going to first figure out what not Q is, and then I can look at parentheses, not P, arrow, Q, and not Q. So Q is true, false, true, false. Not Q is false, true, false, true. So this is an and, where I'm looking at the column if not P, then Q, and not Q. So in an and, if you have true, false, it's false. True, true is true. True, false is false. False, true is false. So we should have a false, true, false, false. Okay. Now I could do the whole statement, the bracket, parentheses, if not P, then Q, and not Q, then P. So again, we have to be really careful about our order. So let me ignore all these previous columns. We're going from this last column that we did all the way to P. So it's a little awkward saying false to true. So again, we might want to just go ahead and write false, true, false, false, and then P is true, true, false, false. So we can see the proper direction, right? We're going from false to true in a conditional statement. That's true. True to true is true. False to false is true. False to false is true. So this conditional statement is always true. It doesn't matter if my original P and Q statements are true or whether they're false, the conditional will always be true. So recall that this is a tautology. It's always true. However, since this is a conditional statement, and it's a conditional statement because the last thing we figured out, and you can look at the grouping, was the conditional statement. So this is a conditional statement that's always true, and in that case we call it an implication. So an implication is a special tautology. It's a conditional tautology. And then also recall that if this were all false, it would be a self-contradiction. So we're just adding on one more vocabulary word, which would be implication. We're going to apply this, and this often happens. Companies usually make claims about their product, and a lot of times the product doesn't work. So the question usually becomes, can I sue them? Let's look at my fake example. An advertisement makes the following claim about their face cream, acne free. So the claim in blue is, if you use acne free and apply it twice daily, then you will not get pimples. Okay. So part A, construct a truth table for the claim, and then B has some conditions. Let's suppose you do use this acne free, you forget to apply it twice daily, and you get pimples all over your face. Under these conditions, is the claim in the advertisement false? Can they be sued for making a false claim? So our solution to part A is to construct the truth table. So we need to translate our statement into symbolic form. I see that there's an if, then an and. So I have, you use acne free, apply it twice daily, there's a comma, then you will not get pimples. So again, I have to assign letters to my simple statements. I'm going to let P be the statement, you use acne free. And then apply it twice daily. That's actually a command. That's not a statement. And it also has a problem. It has the word it in there. So it is referring to the product acne free. So I'm going to have to play around with Q and say, you apply acne free twice daily. Okay. And then let's look at the last statement, you will not get pimples. We want to be careful that when we define our statements, we don't want to include negations. Now, it's not wrong to let my third statement R be, you will not get pimples, but typically we want our statements to be as simple as possible. So ignore the negation, and I'm going to write R as you will get pimples. So now I know what my statements are. I can translate my original statement into symbolic form. So this would be P and Q arrow not R. Since I have a comma after daily, that means P and Q, that's grouped together. So parentheses P and Q, and then our arrow, not R. Now we have the conditional form of our statement. I'm going to go ahead and create my truth table. I have 3 statements, P, Q, R. So remember, 3 statements means you're going to have 8 rows of truth values. So half of that is 4. P, I'm going to have that be 4 true, so true, 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 and then 4 false. Q is going to do half that. So from 4 we'll go 2 and 2. So 2 trues, 2 false, 2 trues, 2 false. And then R is going to alternate true, false, true, false. Okay, I'm going to build up. I need to first work within my parentheses and figure out what P and Q is. So that would be these first 2 columns, PQ. It's an and, so, and we're going true, true. That would be true, true, true. That would be true. But look at the rest of them. Remember, it's an and. So if you have just one false, the whole thing's false. So the true false is false, true false is false, then false true, false true, false false, false false. Those are all false. So this is going to be true, true, and the rest of them are all false. Well, we figured out what was inside the parentheses. Now I need not R, since it's not listed. If R is true, false, true, false, true, false, true, false, not R is false, true, false, true, and so on. Our conditional statement is going from P and Q to not R. So this is conveniently in the correct order. True to false for our statement if P and Q, then not R. It's going to be false. True to true is true. False to false is true. False true is true. False false is true. False true is true. False false is true. False true is true. So remember that a conditional statement is always true except for in the case where you're going from true to false. So we're done with part A. We created our truth table. B says, suppose that you use acne-free. That means that P is true. You forget to apply it twice daily, so Q is going to be false. And you get pimples all over your face. So R is going to be true. You get pimples. Let's see if we can sue this company. So we're looking for the particular row that is true, false, true. So true, false, true, that's going to be the 3rd row down. And unfortunately, the company told the truth, so they cannot be sued. And this is our part B. Use acne-free. You forgot to apply it twice daily, and you got pimples. Under these conditions, is the claim in the advertisement false? No. It's true. So can they be sued? No, cannot be sued. This is actually very typical. Companies, again, make claims all the time. So if you take their legal document, their claim, and break it down into simple statements, create a truth table, then if the product doesn't work and that final column is false with your given conditions, then yes, you can sue them. Okay, well, let's move on to our biconditional. That would be our if and only if. The biconditional, which is our double arrow. What's nice about the biconditional, and this is true of our and in our or statements, is that the order really doesn't matter when you're filling in the truth table. P if and only if Q, Q if and only if P, same truth values. You can look at it like kind of like an equal sign. We'll let P be a number is even, Q will be a number is divisible by 2. And just for your information, this is the definition of an even number. A number is even if it is divisible by 2. Likewise, if a number is divisible by 2, then it is even. So when we look at the statement, a number is even if and only if that number is divisible by 2, that's going to be our connective, if and only if. So a number is even, that's P, double arrow, Q. So when is this true, when is this false? Two simple statements, going to be true, true, false, false for P, true, false for Q. So let's say P is true and Q is true. So we do have an even number, and we do have a number that's divisible by 2. So a number is even if and only if that number is divisible by 2, that's true. Name any even number you want, it will be divisible by 2. Name any number that's divisible by 2, it will be even. What if we have a true false? Let's say we do have an even number, but it's not divisible by 2. Can that happen? Can an even number not be divisible by 2? So think of all the even numbers, 2, 4, 6, 8, and so on. They're all divisible by 2. So true, false, in a biconditional is false. What if we had a false true? What if we have a number that was not even? But Q is true. The number is divisible by 2. So for example, 3. 3 is not even. Is 3 divisible by 2? No. So that's not possible. It's not possible to have a number that's not even if and only if the number is divisible by 2. So in this case, the biconditional is false. What if we have a false false? What if we have a number that's not even, and then we have a number that's not divisible by 2? A number is even if and only if that number is divisible by 2. So that would be false false. So a number is not even if and only if the number is not divisible by 2. That's actually true. This is the truth table for biconditional. Notice that it's true if both sides are true. It's also true if both sides are false, because it has to match up on both sides. Either both sides have to be true or both sides have to be false for the biconditional to be true. Otherwise, if you have a true false or a false true, the biconditional is false. Again, you don't have to memorize these. You should have the table available for reference for your quizzes and your final though. So example 4, we want to construct a truth table for parentheses P or not Q, and then if and only if Q. Is this statement a tautology, a self-contradiction, or neither? Well, first of all, our two statements, we would get a true true, false false for P, and a true false for Q. Again, I have to work within the parentheses first, P or not Q. I don't have not Q listed, so I have to first figure out the truth value for not Q, which would be false, true, opposite of Q. And now I can do P or not Q. So it's an or statement. I'm looking at P, not Q, with an or. True, false is true. True, true is true. False, false is false. False, true is true. So for this or statement, it's going to be true, true, false, true. And now I can figure out whether the complete statement is true and when it's false. So this is our biconditional. On one side, I'm looking at the last column we had, which was P or not Q. And the other side, we're looking at the column for Q. So here, this would be a true, true matches up. This is going to be true. False, true does not match. Biconditional is false. True, false does not match. The biconditional is false. False, true does not match. The biconditional is false. We constructed our truth table. Now there's another question. Is the statement a tautology, a self-contradiction, or neither? Well, in this case, it's neither. I don't have all truths. I don't have all false. All right, let's look at example 5. We're going to construct the truth table for parentheses P and Q, if and only if parentheses if P then not Q. So I only have two simple statements, P, Q. So again, true, true, false, false, true, false, true, false. I'm going to look in the first set of parentheses, which would be P and Q. I have P listed, oops. I have P listed and I have Q listed, so I can go ahead and figure out P and Q. So it's an and, true, true is true, but the rest of them should be false. True, false is false, false, true is false, false, false is false. And now I need to follow order of operations and work with the next set of parentheses. If P, then not Q. So P is there. I don't have not Q. I have to first figure out what not Q is, which would be a false, true, before I can figure out the truth value for if P, then not Q. So again, the order matters. Here we're starting with P, and we're going to not Q. That would be a true to false, which is false. Sorry. It won't erase. Okay, now let's look at the rest of these. True to true is true. False to false is true. False to true is true. So these are all, keep doing that. These are all true. So it's false, true, true, and true. Now I have the two pieces to my biconditional. I have the first piece, P and Q, if and only if, and the other piece would be if P, then not Q. So I will be looking at the column with P and Q and the column if P, then not Q. And it's a biconditional, so both sides have to match. So I have a true, false. It does not match. So my biconditional is going to be false. Then I have a false true. Keep doing that. False true doesn't match, it's going to be false. False true does not match, going to be false. False true does not match, it's going to be false. So the biconditional is, I'm going to hurt myself. I'm going to totally suck. False, 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 false. Sorry. So it's always false. So in this case, since it's always false, this is going to be a self contradiction. Okay. Our last example in this section puts together all the symbols that we've learned so far. So notice that this has grouping symbols, it's got parentheses, it's got brackets, it's got ands, ors, if thens, if and only if. It's got them all. And it has 3 statements. So it's going to be one of those larger truth tables. Let's start with our statements P, Q, R. I need to list the truth values. So we have P is going to be 4 truths and 4 false. Q is going to be 2 and 2. 2 truths, 2 false. 2 truths, 2 false. And then alternate with R, true, false, true, false. All right. I have to follow my order of operations. So I have brackets. Within the brackets, I have parentheses. So my innermost parentheses would be the P and Q. That's where I start. I have P listed, I have Q listed, so I can easily figure out P and Q. So looking at the column for P, the column for Q, true, true is true in an and statement. True, true is true. But true, false is false. And false, true is false. False, false is false. Still working it within my bracket, I now have a or, not R. Not R is not listed, so I have to first figure out not R before I could figure out that bracket, which is parentheses P and Q, or not R. So R is alternating true, false, true, false, so not R would be alternating false, true, false, true. Now my or statement will be these last 2 columns, P and Q, and not R with an or. True, false, and an or is true. True, true is true. False, false is false. False, true is true. False, false is false. And then the rest should be, ooh, no, not all. False, true is true. Ooh, false, false is false. False, true is true. We have this word alternating thing going on. So true, true, false, true, false, true, false, true. Now I have another set of parentheses. If P then not Q. That would be the next thing I'm going to evaluate. However, I don't have not Q listed, so I have to first figure out the truth value for not Q before I could figure out if P then not Q. So not Q is going to be false, false, true, true, false, false, true, true. And now I have to be careful with order because this is a conditional statement. So I'm going to kind of scratch out this stuff up here. We are going from P to not Q, and it has to go in that order. So we're going true to false, which is going to be false. So this is difficult to see. So again, what I'm going to do is just do a little bit of scratch work. I'm going to go ahead and write down the truth values for P as true, 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 false, 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 false. And then not Q is false, false, true, true, false, false, true, true. So a conditional where we go true to false is false. True to false is false. True to true is true. False to false is true. False to true is true. Okay, let's put it all together for our statement, which would be brackets and then parentheses P and Q. Let's see if I can fit all this in. Or not R. If and only if, parentheses, if P, then not Q. Okay. I am looking at, I'm going to go down below to indicate which columns I'm looking at. So this is a biconditional that goes true, false. So they don't match up, that's false. True, false. Don't match up, that's false. False, true. Don't match up, that's false. So the first three values would be false, false, false. And then the next would be a true, true, which does match up, so that's true. And then I have a false, true, so that's going to be false. True, true is true. False, true is false. True, true is true. Wow. Well, it doesn't ask for it, but this is not a tautology. It's not a self-contradiction. It's a neither. And that is the end of this section.